Okay, so in this video we're going to have a look at simultaneous equations, and particularly these quadratic ones here where we have straight lines meeting curves or meeting circles, and hopefully you'll remember this from GCSE maths. And again, I'll link in the description all the videos on quadratic simultaneous equations there, so you can always have a look and make sure that you are up to date on all of those. And we're just going to start off with some questions which are relatively similar to those in the GCSE, and later on we're going to have a look at some where we've got some involving completing the square, and another where we're looking at the discriminant as well. But again, I'll link the videos for those in the description to make sure that you've obviously got all the knowledge there for those particular elements of this topic. So we're going to start with this question, so grab a piece of paper, grab a pen, make some notes, and we'll have a look at this question here. So we've got solve these simultaneous equations, and the first one we've got x plus y equals 5, and the second one there we've got x squared plus 2y squared equals 22. Now, thinking about obviously how we go about this, we need to substitute one equation into the other, and as I said, obviously make sure that you check out the other videos on this, because I am going to assume some knowledge of different elements like factorising quadratics and expanding double brackets and all of those little elements that are involved within this topic. So I'm not going to go over those bits to the same extent that I have on some of those videos that I've linked below. So obviously if at any point you're not sure on any of these elements, do go check that out and sort of bring yourself up to speed on some of those first. But in order to sub this in, we need to swap around or rearrange that first equation there, the x plus y equals 5, so we can make it either x equals or y equals. Now what I always like to do is first of all have a look at this equation. Now, if there is a coefficient in front of x or y, I will always rearrange it to avoid having a fraction. I'll move the piece over that has the coefficient. So for example, if it was x plus 2y, I'd move the 2y over. Now in this case, obviously neither of them have a coefficient greater than 1, so we don't need to worry about that too much. So I'm going to have a look at the next equation there. Now the next one we've got a 2y squared, and it doesn't really matter, but I'm going to avoid having to substitute into that piece there. So I'm going to make x the subject so that I don't have to substitute into the 2y squared piece, just to save myself a little bit of time. So I'm going to make this first equation here x equals, so I'm going to minus y to the other side. So we get x equals 5 minus y. Now I can sub that in place of the x squared in the second equation there, so I can replace this x squared with the 5 minus y. And if we sub that in, let's see what we get. We get 5 minus y in brackets squared plus 2y squared, and that equals 22. Now it wouldn't be particularly difficult to do it the other way around, it's just that I'd have to square, obviously if we rearranged it to make it say y equals x minus 5, I'd have to square that and then just times everything by 2, so it's not particularly stressful to do so. It's just a little bit easier in my eyes to just sub it into this piece. So if we expand this double bracket here, we get 2 lots of 5 minus y, and expanding that, obviously you can still write this out if you want. You can write out 5 minus y brackets 5 minus y, but I'm just going to expand that and assume that we're okay expanding it from a squared bracket here. So 5 times 5 is 25. You get 5 times negative y, which makes minus 5y, and we've got 2 of those, so that's minus 10y. And then we've got negative y times negative y, which is positive y squared. And then we're going to add to that this 2y squared, and it equals 22. Now I just want to rearrange that, make sure all those squared pieces are at the start. So we've got the 2 of them there, we've got the y squared and the 2y squared, and that gives us 3y squared at the start. Take away the 10y, and then we've got a positive 25, and that all equals 22. Now we know when solving equations or quadratics, we need to make it equal 0, so we need to minus that 22 from both sides. That's going to make it equal 0, and then we can solve it. So if I write that out, once we've made it equal 0, we've got 3y squared minus 10y plus 25 take away 22, which is 3, and that equals 0. Now we just need to factorise that to solve it. So factors of 3, we can have 1 and 3, and we've got a 3y squared there. So in our bracket we're going to have a 3y and a y in the other bracket. Our factors are 1 and 3, and we're trying to make negative 10. So we want to make negative 9. Obviously one of them is going to get tripled, so minus 3 over here, and minus 1. And we get our 2 solutions there. For the first bracket, we get y equals positive 1 over 3, because we've got that 3y there. And for the one on the right, we've got y equals 3. Obviously just solving quadratics there, and again that video is linked in the description. So on to the next step then. Now we've got our 2 solutions for y. We have 1/3 and we also have the 3. We just need to sub that back into the equation up top, just to make sure we get our value of x as well. Now not forgetting, it says x plus y equals 5. as our equation there, we just need to sub in these two values and get our corresponding values of x. So for the first one, y equals a third, and it says x plus y equals 5. So we've got x plus a third equals 5, and obviously we just take a third away from 5 to get that, and x will equal 4 2/3. And for the next one there, we've got y equals 3, so we have x plus 3 equals 5, and we can just take that away, take the 3 away from the 5, and we get x equals 2. And obviously not forgetting that obviously these are paired up. So we've got our two solutions here. We've got y equals a third and x equals 4 2/3. And for the other one there, we have y equals 3 and x equals 2. So don't obviously forget to pair those up and make sure that you get them the right way round, but that is how we go about solving these simultaneous equations, and hopefully that's obviously a nice reminder from GCSE, quadratic simultaneous equations, so don't forget to check those out because I'm only going to go over this one question for you. Obviously there's lots of different types of questions and lots of differences that can come up in each particular one, so I'm going to get you to have a go at these two questions and obviously see which bits sort of throw you, which bits obviously you find difficult in the process, but obviously here are two for you to have a go, so let's have a look at those now. Okay, so there's different elements in both of these questions, might be different things that throw you on both of them, but just have a go, see what you get on these questions, see where you make a mistake, and if you do, and we'll go over the answers in a sec. Okay, so for the first one then. Now, I'm going to make this one make it x equals. Obviously, because we've got the coefficient of y there, if we make that x equals, it's just going to avoid having any fractions. So we've got x equals 1 plus 2y, and that's what we need to sub into our equation below. Obviously, if we did make it y equals, we'd end up having to divide by 2 at some point to make it y equals or negative 2, depending on how you rearrange it. And obviously, it's a lot easier for us to expand a double bracket without any fractions in there. So if I sub that in, x squared is now 1 plus 2y. So we've got 1 plus 2y squared plus y squared equals 13. There we go. Expanding that bracket out, you get 4y squared. Obviously you can write out your double brackets. We've got two lots of 2y, so that's 4y, and then 1 times 1, which is 1. And I've rearranged that into the normal format as well, but feel free to write out your double brackets and expand it and then rearrange it. I'm just trying to save a little bit of time and space here. And then we're also going to add that y squared, and that's going to equal 13. We are going to take away that 13 as well, so you could take it over at that point if you want. I'm going to take it over in the next step. So let's join up these y squareds. That gives us 5y squared in total, plus the 4y, and I'm going to move that 13 over now rather than writing out two lines. We've got 1 at the end, take away 13, which is going to leave us with minus 12, and that will equal 0. There we go. And then we need to factorise this. So thinking about our factors here, we know we're going to have a 5y in the bracket as we've got a 5y squared and a y in the other one. And our factors for 12, we could have 2 and 6, 3 and 4, 1 and 12. We're trying to make 4. One of them is going to get times by 5. So I think it's going to be 10 and 6. So that could be, our factors are 2 and 6. There we are, so we've got positive 10, take away 6, so plus 2 over here, that'll make positive 10, take away the 6. Obviously just take your time with the factorising part, you might not spot the factors straight away, so you just have to just test them out and just make sure that you get them okay. So obviously we've got our two solutions here, we've got y equals positive 6 over 5, and we've got y equals negative 2. And obviously we just need to sub those back into the equation. So if we sub those in, let's have a look. Up here we've got x is equal to 1 plus 2y. So we've got for the first one there is 6 over 5, and let's just swap colours for this. So if we have a look, we've got x equals 1 plus 2 lots of 6 over 5, which is 12 over 5. There you go, if we double that, that's 6 over 5. And 1 is 5/5, so if we add them together we get x equals 17 over 5. There we go, adding 5/5 to that 12/5 there. And for the next bit we need to sub y equals negative 2 in, so for that one we've got x equals 1 plus 2 lots of negative 2, which is minus 4, so 1 minus 4 equals negative 3. There we are. So we've got our two solutions. We've got the first one there, which is y is 6 over 5, and that gives us x is 17 over 5. And for the other one, we've got y equals negative 2, and that gives us the x equals negative 3. And there's our two solutions. Right, on to the next one then. So if we sub these in, let's have a look at how we're going to do this. So I'm going to make it x equals, as we have a coefficient of y squared, I want to substitute into this x squared part here. So if I rearrange this first one to make it x equals, we get x equals 2 minus y, taking that y over, and then I'm going to sub it in place of the x squared. I've got to be careful though, because it's negative x squared, so if anything did trip you up on this question, it'd probably likely be that part there. So if I sub that in, we get 4y squared, and we're going to take away this x squared, and x is 2 minus y, so take away 2 minus y squared, and that equals 11. Right, so if I work out 2 minus y squared to start with, and I am going to do this separately this time because that takeaway there, negative y times negative y gives us y squared. We have two lots of negative 2y, so negative 4y, and then we have plus 4. Now as we're taking that away, we're taking away all of those pieces, so if I imagine that's in a bracket there, and essentially it's like timesing them by negative 1. So they're all going to change symbols. And when we get that, we get 4y squared. So we're going to get minus the y squared in that bracket, plus the 4y, and then minus the 4 at the end, and that's going to equal 11. So you've just got to watch out with that because all the symbols have changed there. So I'd imagine if people did make a mistake on that, that's where they do it. Now we can join up these y squareds. So we've got 3y squared, and then we've got the plus 4y, and we've got minus 4, we're taking away 11, so minus 15, and now it equals 0. And we can go about factorising it again. So factorising this, we know we're going to have a 3y in the bracket, and a y. We know that our factors here can be 1 and 15, or 3 and 5. Well, let's just have a quick think. Let's just write this down, 1 and 15, or 3 and 5, and we're trying to make 4 in the middle. One of them's going to triple. So which one could we do? We could triple the 3, that makes 9 and 5. So we want the 3 over here, the 5 over there, and we want to have positive 9, take away 5, so positive 3, take away the 5. So we've got our two solutions again. We've got y equals positive 5/3 for the first one, and y equals negative 3 for that second one. And then obviously we just need to sub that in, find our values of x, and obviously our equation up there is what x plus y equals 2. So we've got x plus y equals 2. So for that first one there, negative 3, sorry, what do we add to that to get to 2? Well, x is going to have to equal 5 for that one. And the next one's a little bit more complicated because we have x plus 5/3 has to equal 2. And 2 is 6/3, so we need to add an extra third in there. So our value of x is going to be 1/3. There we go. And that's going to make sure that those two values there add up to the 2 that we have in our equation. So there we go, there's our two solutions. We had y is 5/3 and x is 1/3. And then for the other one there, when we've got when y is negative 3, x equals 5, and there's our two solutions. Right, okay, so we're going to have a look at a slightly different question now before we move on, and let's have a look at that one. Okay, so looking at a different type of simultaneous equation here, only in the way that it looks, and it says here obviously solve the simultaneous equations. We have y plus 4x plus 1 equals 0, and y squared plus 5x squared plus 2x equals 0. So this looks a little bit different to ones that we've seen obviously previously. Now again, I'm going to take the same approach. I want to make one of these equations y equals or x equals, and looking at that first one there, we can see that obviously there is a coefficient of x. We've got a 4x there, so I'm going to avoid making x the subject and making a fraction out of this, but I'm going to go with making y the subject. That's not the nicest here because when I do move those to the other side, I get quite a lot of negatives here. So if we make that y equals, we'll minus the 4x to the other side, so we get minus 4x, and minus the 1 over as well, so we get minus 4x minus 1. Now that's not the nicest because that's what I'm going to substitute into the next equation, and obviously just bearing in mind here, it's a nice one to pick as well because if we had have made it x equals, we'd have had to have subbed it into this 5x squared, and we'd have had to have subbed it into the 2x, and neither one of those would have been very nice to sub this fraction into. So as it stands, we're going to substitute it in place of the y squared here, so let's go about doing that. So obviously our y now is negative 4x minus 1, so we have negative 4x minus 1, and that's all in brackets squared. And we're going to add to that 5x squared, and we're going to add the 2x to that as well. There we go, let's just rewrite that because that's a bit messy. There we go, 5x squared, and we're going to add the 2x, and it all equals 0, so that's quite nice. We don't have to move anything over at any point. So if we go about expanding this bracket, and as it's not as nice a bracket, I might just write it out so I can just see it. So we've got negative 4x minus 1 and we're going to times that by another negative 4x minus 1. So negative 4x times negative 4x makes positive 16x squared. Then we have negative 4x times the negative 1, which makes positive 4x, and the same below, another positive 4x. So that makes 8x's in total, so plus 8x. And then negative 1 times negative 1 makes 1. And again, we're going to add to that the 5x squared and the 2x. There we go, and that all equals 0. Now if we tidy this all up, we've got the 16x squared and the 5x squared, and that makes 21x squared. We've got the 8x and the 2x, and that's going to make 10x. And then we've got the plus 1 at the end. There we go, and that equals 0. Now that's not the nicest there, but in terms of our brackets, to make 21, it's unlikely going to be 21x and x. It might be, but it's more likely that it's going to be 7x and 3x in order to make that 21x squared. And obviously, as it's a 1 at the end, our only factor options are 1 and 1. So it's got to be 1 and 1 in both of these, and as it turns out, look, that's going to make a nice 10 in the middle there. We've got 7x and a 3x when we expand that. So it's 7x plus 1 and 3x plus 1. Now again, we can get our two solutions from this. So x is going to equal, for the first one, negative 1/7. And for the one on the right there, we've got x equals negative 1/3. There we go. And there's our two solutions for x. Now we just need to go about substituting that back in and finding out our y values. But again, these aren't very nice values to substitute in. But we have our equation up here, y is equal to negative 4x take away 1. So y equals negative 4x take away 1. So we've got negative 1/7. So for that first one there, we've got when x equals negative 1/7, y is going to equal negative 4 multiplied by negative 1/7, and then take away 1. Obviously, nice and easy if you have a calculator. Negative 4 times negative 1/7 is positive 4/7. So we have 4/7 take away 1. And 4/7 take away 1, well 1 is 7/7. So if you take away 7 from the 4 on the top, that leaves you with negative 3/7. And there's our first one. For the next one, if we sub in x equals negative 1/3 and just follow the same process, then we have to do y equals negative 4 multiplied by the negative 1/3, and then again take away 1. Negative 4 times negative 1/3 is positive 4/3. Take away 1, 1 is 3/3. So 4/3 take away 3/3 leaves us with 1/3. And there's our two solutions. So we had when x is negative 1/7, y equals negative 3/7. And for the other one there, we had when x is minus 1/3, y equals positive 1/3 there. Okay, so there's our two solutions for that question. Just obviously showing you that obviously if they're written slightly differently, if they're not arranged in a way that we've seen before, we can still take the same approach and obviously just forming and solving that quadratic and subbing it back into our equation. So there we go, there's one of those, and here's one for you to have a go at. Okay, so a very similar looking question, so pause the video there, have a go at this one, I'll go over the answer in a sec. Okay, so this one's a little bit nicer than the last one, purely because when we rearrange this first equation, we get y equals, and we get positive 2x when we add that over, plus 4. So it's not as nasty because we don't have that negative bracket to expand. But we are going to substitute this in, again, into the nicer piece again, which is the y squared there, rather than the 2x pieces. So if we sub this in, to start with, we have 4x squared. And we're going to add to that y squared. Now y is 2x plus 4. So we have 2x plus 4 in brackets squared. Then we're going to add that 20x and it all equals 0. So if we go about expanding this bracket, we have 4x squared at the start. Expanding that bracket there gives us 2x times 2x, which is 4x squared. 2x times 4 is 8x, and we've got two of those, so we have plus 16x. 4 times 4 is 16, so we get 16. And then plus 20x. There we go, and that all equals 0. Now we just need to tidy this up. So if we tidy this up, we've got those two 4x squareds to add together. So we have 8x squared. Then we've got a 16x and a 20x. That makes 36x. And we have the plus 16 at the end. There we go, and that all equals 0. Now at this point here, we can actually simplify this down a little bit. You can actually factorise it at this point, but as they are all even there, and in fact, they all divide by 4. So we can divide everything by 4 and just simplify this equation as it equals 0 on the other side. So if we do that, we get 2x squared plus 9x plus 4 equals 0. And then we can go about factorising from here. So with a 2x squared at the start, we know one of the brackets is going to have 2x in, and our other bracket will just have the x in, and we want to factorise this. So our factors are 4. We can have 2 and 2, or we can have 1 and 4. Now, as there's a 9 in the middle, we're going to want 4 over here and 1 over here. That's going to make 8 and 1, and that makes the 9, and they're both positive, so both positive there. So we've got x equals negative a half for the first one, negative 1 over 2, and we have x equals negative 4 for this one on the right. And then if we go about substituting that back in again, y is equal to 2x plus 4. So if we write that out again, y equals 2x plus 4, and sub these values in. So when x equals negative a half, y equals 2 lots of negative a half plus 4. 2 lots of negative a half is negative 1, add 4 is 3. So there we go, we get 3. And for the other one, when x equals negative 4, y is going to equal 2 lots of negative 4, add 4. 2 lots of negative 4 is negative 8, add the 4 is negative 4, so y equals negative 4. Right, there we go, so we've got our solutions there. We had when x is negative a half, y equals 3, and for our other one there, we've got when x is negative 4, y is also negative 4. And there's our two solutions. Right, okay, so that is the bulk of our questions done. Now we're going to have a look at something slightly different, so here that is. Okay, so as I mentioned at the start, some of these questions involve some slightly different skills, and this question here, if we read it through, it says, by eliminating y from these simultaneous equations, show that x squared minus 6x plus 7 equals 0. And then it says, hence solving the simultaneous equations, giving your answer in the form a plus and minus root 2, where a is an integer. Now that little format over there, if I just highlight this, the a plus and minus root 2 comes from two different processes. Either we're going to put it into the quadratic formula without using a calculator, or we're going to complete the square and leave it in completed square form. Now I'm going to opt for completing the square here. It's a lot quicker and easier. So obviously I'll make sure that completing the square and solving using completing the square is linked in the description. So do check that out if you're not sure. But we're going to obviously involve a different process here, and that is going to be completing the square. Now if we go about having a look at this, if we start with this first part, showing that x squared minus 6x plus 7 equals 0, we're going to solve these simultaneous equations like we normally do. Now it says by eliminating y, and that first equation is already y equals, so all we need to do is sub that in place of the y there in that second equation where it says xy. So if we sub that in, we've got x lots of, and y which is x plus 6, so x lots of x plus 6, take away 2x squared equals 7. So if we expand this first bracket out, x times x is x squared plus 6x, and then we have minus 2x squared, and that equals 7. If we tidy up those x squared pieces, we've got an x squared minus a 2x squared, so that's minus 1x squared, or minus x squared, plus 6x equals 7. And obviously it wants to show with a positive x squared, so we need to move it all to the right hand side now. So if we move it over to the right hand side, if we move the x squared over first, we get 6x equals, I'm going to slot it in front of the 7, x squared plus 7, and then minus that 6x over, and we get 0 equals x squared minus the 6x, which I'm going to put after that, plus 7. There we go. And obviously it wants us to write equals 0 on the right hand side, so that's fine. We can just get rid of that 0 now, write it on the other side, and there we go, it equals 0. And that's shown what we've been asked to show there, x squared minus 6x plus 7. So the actual solving of, well, the actual rearrangement of these simultaneous equations, subbing it one into the other, not too complicated in this one. But now it says, hence solve the simultaneous equation, giving your answer in the form a plus and minus root 2. And that gives us a hint there that it doesn't factorise. And if you have a look, we've got a 7 at the end. And let's think, if it was 1 and 7, we couldn't have minus 7 plus 1, because in order to make the negative 6 in the middle, because it's positive 7 at the end. Likewise, we couldn't have minus 7 minus 1, because that would make negative 8 in the middle. So there we go, it might look like it factorises, but actually it doesn't in this case. So we need to go about completing the square. So if I write this out, we've got x squared minus 6x plus 7 equals 0, and we're going to complete the square for that. So the 6 in the middle, the negative 6, we're going to halve that coefficient, so we get x minus 3 in brackets squared. That would give us plus 9 at the end. We don't want plus 9, we want plus 7, so we need to take away 2. There we go, and now that equals 0 again, and just in completed square form. So now we can go about solving using this. So if we add 2 to the other side, we get x minus 3 in brackets squared equals 2. And then we can square root both sides. So we get x minus 3 equals plus and minus root 2. And then add the 3 over, and we get x equals 3 plus minus root 2. Now obviously there's both our x values. Now I'm going to get rid of what's on the left here. We're going to have a look at getting our y values. So obviously our 2x values there are given to us. We have 3 plus root 2 and 3 minus root 2. So let's have a look at how we'd actually go about writing this next step then. So when we have x equals 3 plus root 2, what do we get for y? Well, y is equal to x plus 6. Okay, obviously just up here, y equals x plus 6. So if we add 6 to that, we get y equals 9 plus root 2. And there's our first pair of answers. For the other one, where we've got x equals 3 minus root 2, again we just need to add 6 to that, so we get y equals 9 minus root 2. And there we go, there's our 2 pairs of solutions. When x is 3 plus root 2, y is 9 plus root 2. And for the other one, when x is 3 minus root 2, y equals 9 minus root 2. So there we go, just something a little bit different, obviously with different looking solutions there, but following pretty much exactly the same process. So we're going to have a look at one more question before we finish. Okay, so this question is the longest and hardest looking out of the bunch, and we're going to have a read through it before we discuss the processes. So it says, given the simultaneous equations 2x plus y equals 1, and we've got x squared minus 4ky plus 5k equals 0. It says where k is a non-zero constant. Remembering that word constant there doesn't necessarily, it means obviously it's a number that we're looking for, but it's not necessarily an integer. So it's giving us a big hint here that it's not going to be a whole number. And it says show that x squared plus 8kx plus k equals 0, and then we've got some extra little bits to talk about here. It says given that the equation has equal roots, find the value of k. So we're looking at the discriminant there. So again, I'll link that in the description. And then it says for this value of k, find the solution of the simultaneous equations. So let's have a look at what we can do about this. So in terms of showing that x squared plus 8kx plus k equals 0, essentially what we need to do is actually go about solving it using our normal process. So we're going to rearrange that top equation and substitute it into the bottom to eliminate this y here that we have, and let's just highlight that. In the second equation, we want to eliminate this y. If you have a look here, we've got no y's in this equation. So if I rearrange that top one, minus the 2x to the other side, we get y equals 1 minus 2x. And we're going to substitute that into that equation there. So if we sub that in, we have x squared, and let's write it here, we've got x squared minus 4k lots of y, so 4k lots of 1 minus 2x plus 5k equals 0. So now we just need to go about obviously expanding this bracket. So if we expand that out, well, to start with, we've still got the x squared there. We've got minus 4k times 1, which is minus 4k. And we've got negative 4k times the negative 2x. So that's going to make positive 8kx or xk, however you want to write it there. I'm going to leave it in alphabetical order. And we're actually looking at the question over here. Look, we've got that 8kx just there as well. Plus the 5k, and that equals 0. Now having a look, what have we actually got there that we can tidy up? We've got the minus 4k and the 5k, and they're the only ones we can tidy up there. So if we do that, we've got x squared plus the 8kx, and then 5k take away 4k is 1k, so plus k equals 0. And there we go, that matches what we're looking for, x squared plus 8kx plus k equals 0, and there's our final answer there for that part. Moving on to the next bit, it says given that x squared plus 8kx plus k equals 0 has equal roots, find the value of k. Now thinking about the discriminant, and obviously having a look at that video if you're not sure on it, if it says equal roots, that means that the discriminant is equal to 0. Or in other words, when we do b squared minus 4ac, the answer to that will be equal to 0, and that should hopefully allow us to solve and find out what k is. So if we find out what b squared minus 4ac is, we should hopefully be able to work that out. So a equals 1, the number in front of x squared, b equals 8k, what's in front of x there, and c equals k. There we go. And if we sub all these bits into b squared minus 4ac, we get 8k is our b, so we have 8k squared minus 4 times a, which is 1, times c, which is k, so minus 4k. There we go, and that equals 0. So if we expand this bracket here, this 8k squared, that gives us 64k squared minus 4k, that equals 0. And obviously now we just need to solve this. So we can divide both sides by k, and actually we can divide both sides by 4 as well. So I'm going to divide both sides by 4k just to simplify this down a little bit. I'm going to write that in, divide by 4k. So 64 divided by 4 is 16, and divided by the k just leaves us with 1k there. And then 4k divided by 4k is 1, so it's 16k minus 1, that equals 0. There we go. And solving this, add 1 to both sides, we get 16k equals 1, and then k equals 1 over 16. There we go. We did have a hint at the start, obviously, up there, where it said k is a non-zero constant. So there we go. We've got our value. It's not an integer, it's a constant there, obviously thinking about that language. So k equals 1 over 16. Now we can move on to the last part. It says for this value of k, find the solution of the simultaneous equations. Not the nicest part here, but now we can actually substitute this 1 over 16 into our equation. Obviously what we've got up here, we obviously showed it on the left, but it said up here, show that x squared plus 8kx plus k equals 0, but now we actually know the value of k. And if we replace that with the 1 over 16, let's see what we get. We get x squared plus 8 lots of 1 over 16. I'm just going to work this out to the side here. 8 times 1 over 16 is 8 over 16, and 8 over 16 equals a half. There we go. So we've got x squared plus 1 half x, so we could write 0.5x, plus k, which is 1 over 16. There we go, and that all equals 0. And we need to go about solving this. Now that does actually factorise into a double bracket, and we know obviously it has equal roots, so it is going to go into the two of the same brackets, okay? But we need to actually figure out what that's going to be, and there's a not, obviously you might be able to spot this. There are two different ways of going about this, but I like to eliminate these fractions. So in order to get rid of these fractions, I'm going to times both sides of this equation by 16, as that denominator there down here is 16, and that's going to give me 16x squared plus 8x plus 1, that equals 0. And from there, that's quite nice and easy to factorise. We know that they're the same brackets, so it's going to have to be 4x and 4x, as they are equal roots. We've got the same things going in here. There we are. And we know that it's going to be 1 and 1 as our factors of 1 here. So 1 and 1, and it's all pluses there because it's all positive, this equation. So x equals negative 1 over 4. There we go. Obviously from our bracket there, x is negative 1 over 4. Obviously we are finding the solution to the simultaneous equation though, so we still need to find the value of y. And obviously right at the start up here we've got y equals 1 minus 2x. So if we sub that into there, and I'm running out of space here, we've got a lot of working out on this question. We are going to have to do 1 take away 2 lots of x here, and x is negative a quarter. So if we work that out, let's do it up here. We've got what? In fact, let's just do it over here. Y equals 1 take away 2 lots of minus a quarter. Just about fit this in. And that is 1 take away, and 2 lots of a quarter is a half. So it's 1 add a half, as it's take away 2 lots of negative a quarter. So 1 plus a half is 1.5 or 1.5. And I'm just going to leave it as a fraction, 1.5. Right, there we go. So x is equal to negative a quarter, and y is equal to 1.5. A lot of working out on that question there to finish this off, but obviously just thinking about all the similar processes that we've done. So all we did in that first step was obviously sub one equation into the other, rearrange it to make sure it equals 0, it was all tidy there. Then obviously when it mentioned equal roots, that gave us the hint that we were looking at the discriminant, so we just used the discriminant and solved that to find the value of k. And then once we had the value of k, we put that into our equation and solved it as normal. But as it turned out, obviously we only have an equal roots, so we only had the one solution to do there, but we still got our solution for x, subbed it in, and got our solution for y. So there we go, that is obviously a bit of an extension question there, just something else to be thinking about in terms of this topic and where it can go, and all the different parts of maths that you have to be thinking about with this, like completing the square and understanding the discriminant and all those little bits and bobs and all those little intricate pieces within all of these where you can go wrong, like when you've got a minus x squared that you're subbing into, or just watching out with obviously your rearrangements and bits like that. So there we go, that is obviously the end of our quadratic simultaneous equations here. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe. I'll see you for the next one.